Alright, so we're working on the homework now for 13-2. I hadn't underlined anything, so y'all won't know what I did. But anyways, I think I'll start with number 6. Last test, there was an average of a 42-point spread between the kids who had done all their homework and kids who hadn't. 6 got a typo there. Right with a double T. Triangle ABC with right angle C as a hypotenuse of 6. I'm going to draw this out. Some kids don't know how to draw. It's because they never tried. So we have a hypotenuse of 6, a short leg of 3, and angle A is 30 degrees. Find the missing side. It says maybe using 30-60-90 theorem. That's a good idea. 30-60-90 theorem, the hypotenuse is twice the short leg, and the long leg is the short leg times root 3. So this guy right here has to be 3 times root 3. So the missing side AC is 3 root 3. That's what she is. You're supposed to find angle B2. Last I checked, there were 180 degrees in the triangle. 180 minus 90. Minus the 30 that's given is 60 degrees. Hopefully you can figure that out. And you're supposed to find all 6 trig ratios for angle B. So do a little SOHCAHTOA. And my attention is on angle B. Sine of angle B would be the opposite length over the hypotenuse. 3 root 3 over 6. 3 over 6 reduces to a half, so root 3 over 2. The cosine of angle B would be adjacent over hypotenuse, 3/6. We always simplify, that's a half. And the tangent of angle B would be opposite over adjacent, which is 3 root 3 over 3, which is just root 3. Now we got to do the reciprocals. The cosecant of angle B, the reciprocal of sine, would be 2 over root 3. We have to rationalize the denominator. So we multiply the top and bottom by root 3. She becomes 2 root 3 over 3. The reciprocal of cosine is called secant. We flip a half, we get 2 over 1, so just 2. And the reciprocal of tangent is called cotangent. If we reciprocate a root 3, we have 1 over root 3, which we clean up by multiplying top and bottom by root 3, and we get root 3 over 3. Whew. All right, next up will be number 9. Given cosecant of theta is x. Cosecant is every young man's favorite trig ratio because cosecant is a hoe. Cosecant ratio is hypotenuse over opposite. It's a hoe. I'm going to put that x over 1. I'm going to do a lineup operation. I'm going to throw theta in the lower left-hand corner as I do. And the hypotenuse would be x and the opposite side is 1. Find the missing leg here. We'll call her A. A squared plus 1 squared is x squared. Move that on over. A squared is x squared minus 1. A would therefore be the square root of x squared minus 1, and that's all it is. You cannot simplify it. Does not reduce. I don't care who you are, what you smell like, what your last name is. That don't reduce. There's a minus symbol in there. It throws everything off. You cannot take the square roots of those pieces. Now your job is to find the tangent ratio, tangent being opposite over adjacent. You're here, opposite's a 1, that's adjacent. This stuff is easy. All right, number 11. You, who stand 6 foot tall, are standing 43 feet from a 200-foot tall tree. So I'm going to stick figure U out. There you are, 6 foot tall. You're standing 43 foot from a 200-foot tall tree. Remember, there's 6 foot here, which means there's 37 foot of tree left. Because 6 feet is accounted for in your height. You're looking at the top of the tree, and you want to know what angle of elevation is being formed. So here's the angle of elevation you're looking up. The ratio here is 37 over, how far away are you, 43 foot? Oh, that was a 200-foot tall tree, wasn't it? That's 194 foot. So I see opposite being 194, adjacent being 43. I know that the tangent of theta would be 194 over 43. Since I know the tangent of theta is this, what I can do is I can take the arctangent of both sides. Arctangent destroys tangent. That's what they do. They're inverse functions. So go push buttons in a TI-84 and I'll have her. I have already put this calculator in degree mode. That's a kind of a big deal. Got to be in degrees, at least for now. 77.5 degrees. 77.50 degrees if I round to the nearest hundredth. Ta-da! What's on the back side here? You need to do 12, you need to do 13. I need to do 14 because I have not talked about recursive sequences. These are actually on your form quizzes. Who knows if I'll give you another one. I'm just so far behind. But the recursive sequence is kind of funny, and a recursive sequence uses a sub n minus 1 to refer to a previous term. You ever go into computer science, real computer science, when you actually learn algorithms, when you actually learn how to code, it's all recursive thought. But I think most kids can write the sentence for this one. It takes a little while to look at this one. Turns out if you double 4 and add 1, you get 9. If you double 9, you get 19 if you add 1. So a sentence describing this pattern is to double the previous term and add 1. That's what you do. To create this 9, I doubled the term before it, and I added 1. So if a sub n minus 1 refers to a previous term, write a recursive rule. A sub n, which would be the current term. So say I'm at this 9, I've got to look back 1 and double it, and then add 1. Find the 7th term. So what do we got here? 1, 2, 3, 4, 5. I can find a sub 6 by doing twice a 79 and adding 1, which is 159. And then I can find the next term by doubling this and adding 1. So if I double 159, I get 318. If I add 1, I get 319. 17, find the sum of the finite series, which means you need a formula. This is, by the way, geometric. The ratio here being 4/3 over a third is 4. So this is geometric. It's not being done through addition. The sum of n things is the first term, a sub 1, times 1 minus the ratio to the nth power over 1 minus r. Now, position's kind of a big deal here. Look at this thing as powers of 4. This is 4 to the n over 3. Funny, huh? 4 to the 0 is going to be 1/3. 4 to the first over 3 would be 4/3, and so forth. So this guy right here, 65,536, is 4 to some power. That's all she is, 4 to some power. That's what she is. Let's try 4 to the 6th. Not 4 to the 6th. Not 4 to the 7th. There she is, 4 to the 8th. This is 4 to the 8th. However, we're starting at 0. If you use your fingers and you do 0 to 8, you'll come up with 9 fingers when everything's said and done. Or you can do high minus low add 1. But anyways, n is 9. So the sum of 9 things is the first thing, which is a third, times 1 minus the ratio here being 4 raised to the 9th power over 1 minus 4. Should be a decent looking fraction. 1 minus 4 to the 9th is that number. I could just push a whole bunch of buttons in a calculator, but I want to make sure I get the fraction. I got to divide that by a -3. I got a whole number, cool. And then I got to take a third of that, so divide it by 3 again. Oh, worked out nice. 29127. And that is the homework on 13.1. I hope you enjoyed. You probably didn't, but you learned something, and that's the goal of the class. Learn.